In Module 3, Lesson 16, we're going to talk about some things that we've discussed before, but we're going to go a little bit more in depth today. So we're going to look at patterns of multiplication and division related to the numbers 0 and 1. So again, we've had some experience with this. We know a little bit about this, but let's take a closer look and see what we can discover. So I've already pre-filled out some of my whiteboard. As you'll see here, we're going to begin with ones. And we know that 1 times any number is that number. So for example there, I said 1 times 6 is 6. Something you're going to be asked a lot in this lesson is right here, like substitute a variable for a number. So like we can make this general statement that 1, here I'll highlight it in a different color, 1 times any number. So any number can be put in there for that n. Stays that number. See how the variable stayed the same, just like the 6's stayed the same? So like 1 times any number stays that number. So that same number. Okay. That one's straightforward. We know that. We've talked about that in class. You guys have used that. We know that 1 times a number is that number. So if 1 is one product, whatever the other, if 1 is one of the factors, whatever the other factor is also becomes the product. So 1 times 1 is 1, 1 times 10 is 10, 1 times 99 is 99, 1 times 300,000 is 300,000. Like the expression with the letter there shows with the variable, 1 times any number remains that number. Straightforward. Let's see how that relates to division. So ones and division. Ones and division. We've also had a lot of experience with this, but I think it's a little bit more complicated, and I think kids find it a little more tricky just because when you hear the word division, you think it's going to be harder. But remember, division is just the turnaround fact of multiplication. So if we had that example, 1 times 6 equals 6, we could turn that around in a couple of different ways. So we could turn that around. Let's just write that whole fact family, actually. 1 times 6 equals 6. 6 times 1 equals 6. 6 divided by 1 equals 6. And 6 divided by 6 equals 1. So here are my 2 division facts right here, right, from that fact family. And so you'll notice that if I divide 6 divided by 6, so if the 2 things that are being divided are the same, then the quotient, the answer, is going to be 1. So if you, and we can make a general statement about that, we could say n divided by n equals 1. That's an important statement. If you take a number and you divide it by itself, the answer is 1. That's like saying if I have 8 cookies and I'm dividing them with 8 friends, each friend gets 1 cookie, right? So if you have the same number of total things as groups you're putting it into, then each group is going to get 1. Okay. The other way to think of that is, here we'll block that off. Whoops, that's a kind of bad square there, rectangle. Is if I take 6 and if I divide it by 1, it's going to equal 6. So that's like saying if I have 6 things and I put them all into one group, how many things does that one group have? It has 6. So it looks like one group, 6 things, 1, 2, 3, 4, 5, 6. How many things does a group have? Well, it has 6. Whereas up here, with this one, we'd be saying, I have 6 things, and I'm going to put them into 6 groups. 1, 2, 3, 4, 5, 6. Each thing got, each group got 1 thing. Right, so that's how patterns of division work. We can write one more statement for ones here. So we could say any number n divided by 1 equals whatever that number was. So your total divided by 1, your quotient is the total. Those 2 numbers are going to be the same. If you ever get stuck on this, I want you to, like on the side of your paper or a blank piece of paper, write out the fact family. So like if you know what the multiplication facts are for that fact family, turn them around in the division facts. Right? That's a good way to help you understand the division facts. And we talk about that a lot in class, but I'm not seeing it become a habit with everybody, like that if you get stuck to write those out. But it really is helpful for you to see them because you're more familiar with the multiplication facts than you are with the division facts. So turn them around, write out the fact family if you're stuck, and that's going to help guide you. And again, those uh, general rules are that any number divided by itself is 1, or any number divided by 1 is itself. All right, those are our rules for the number 1. We also want to take a look at zeros. Now, this first part is something we've talked about, and you all know, and I'm comfortable that we can move through it kind of quickly. Anything multiplied by 0 equals 0. So any number out there, if you multiply it by 0, it's 0. So if I have 2 groups and I give each group 0 things, they both end up with 0 things. So any number times 0 equals 0. I write it like that. I can write it like 0 times n equals 0. That one's pretty straightforward. Any number multiplied by 0 is 0. So if you see 0 as one of the factors, the product is 0. Let me write that part out. If 0 is a factor, the product is 0. So if either one of the factors is a 0, the product is automatically a 0. That one's straightforward. But let's move on to division because that's where there are 2 different rules here. And I've written them out for you. And let's go through why they are the way they are. On the left side of the screen there, you see 0 divided by 9 equals 0. That we can do. If I start with 0 things, I divide it into 9 groups. Each group gets 0 things. Right? So I have 0 things to start with. I'm trying to divide that up into nine groups. Every group gets the same amount, and that amount is 0. However, if I have 9 things to start with on the right side here, so like if I'm starting with 9 total, or starting with, so if I have a starting with of 9, and I try to take those 9 things and put them into 0 groups, I can't say that each group has 0 things. Like those 9 things haven't gone anywhere, but they also have nowhere to go. So that we call that undefined. We can't divide by 0. You notice at the bottom there, I've written we can't do it. The technical term is undefined. Something you're going to hear a lot in class when your classmates are explaining is we can't do that. We cannot divide by 0. We can write a general statement for that, and that n divided by 0 equals undefined. I get really close to the edge there. Any number divided by 0 is undefined. It means it can't be done. Let's take a look at why, right? Like, so I have, let's see, I have 9 divided by 0 equals 0, equals undefined. See, even I mess up once in a while and say the wrong thing there. So I have 9 things. I'll draw 9 things over here. All right, I have my 9 things. And here are my groups. Notice I have no groups to put them in, right? I have no groups over here that I can put these things into. 9 things being put into 0 groups. Well, the answer is supposed to be how many things are in each group. But there are no groups. So I have 9 things floating off on their own here with no group to put them in. So if I have some number of things and no groups to put them in, then I can't say how many things are in a group because there are no groups, right? It's like saying I have $9 and I'm going to divide that up with 0 people. How many dollars does each person get? Well, there are no people who get dollars. So we can't say how many dollars each person gets. That's undefined. We can't do it. I can't take $9 and split it up with 0 people because that money can't just magically disappear. It can't be put somewhere. It still exists. There's still $9. It just can't go anywhere. Right? 9 divided by 0 is undefined. We cannot do it. 9 or any number divided by any number divided by 0 equals can't be done. This is important because the instinct of kids is to say that 9 divided by 0 is 0. But you have to think a little bit more deeply about it because that isn't true. If I have, again, $9, I split up into 0 groups. That's like saying each group gets $0, but what happened to the $9? It still exists. It just can't be split into 0 groups. You can't take something and split it into something that doesn't exist. I understand that that's a bit complicated. We will talk about it in class. We'll go over it. We'll talk about examples. We'll talk about other ways that you might be able to make a connection to. But the key points here, here let's do one more slide. The key points are for the whole lesson: n times 1 equals n. Any number times number times 1 equals that number. Okay. We have 0 things divided into 9 groups equals 0. 0 divided by, oops, I should have made that an n, I'm sorry. Divided by any number equals 0. And last but not least, n divided by 0 equals undefined. We can't divide a number by 0. And again, the difference between those two division things, let me clean that up actually before I say that point, last point. I said one thing and wrote another there a minute ago. The difference between those things being, if I have 0 things, so I have $0, but I'm going to split it up amongst 5 of you, you all get $0. That makes sense. If I have 0 to give you, but there are 5 of you, you all end up with an equal amount, and that amount is 0. That's why this top one can be done, right? I have nothing, I have no cookies to give you, but there are 5 of you. Well, everybody ends up with 0 cookies. That makes sense. And I think when you're talking through these problems or thinking through them in your head, use physical objects: candy, cookies, money, marbles, whatever, like markers, pencils, whatever you can think of that makes sense to you. Think about, like, if I had 0 of these, could I split it up amongst my friends? Well, yeah, they would just get none. Whereas the other one, again, is if I have those, I have 5 cookies, but I have 0 people to split them up amongst, including myself. I'm not a person that can be part of a group either. Then we can't say how many cookies everybody gets because there's nowhere to put them. There's no group to give them to. No, we can't have equal groups if we don't have any groups. And so those are the differences between those two things. And again, we'll continue to go over it in class. All right, guys, keep up the good work, and let me know if you have questions during class.